back to our BIM series. I'm Venkatesh, and in this session, we are going to talk about architecture in BIM. We are going to see how BIM in architecture is transforming planning and designing, that is, architectural planning and designing. So let's get started with it right away and see how the integration of BIM in architecture is helping us produce smarter, more efficient, and sustainable building designs right from the conceptual stage up to the construction stage. So let's get started with it right away. So when we talk about architecture in BIM, or let's say any other discipline in BIM, it may be structural engineering, or it may be MEP, it can be any discipline in BIM. If you want to handle the entire project in BIM, only knowing the modeling tools or only modeling the designs in any of the BIM softwares won't help you handle the entire project. Along with the modeling tools, understanding the concepts and the design principles are equally important. So this is what exactly we are going to do in today's video. We are going to start it from the scratch. That is, we are going to understand this with the help of a small residential building design and model it in Revit. So we are going to understand the concepts of space planning, and then we are going to design a small residential house based off the concepts on residential house planning, and we are going to produce the same, or we are going to model the same design in Revit. So when we talk about space planning, there are different types of space planning. So in this video, we are going to take up the example of a small residential house. But in the upcoming videos, we are also planning to start a new YouTube channel only for BIM. So either on that channel or on the same BIM series, we will be taking other space plans as well, like how to develop space plans a for a commercial space, for a restaurant. It could be a sports complex, it could be a cafe, it could be anything, it could be a hospital building. So we will discuss the concepts in the upcoming videos, but in today's video we are going to take the example of a small residential house. We are going to discuss the concepts involved in planning the space, and we are going to design the space, and we are going to model the same design in Revit. So let's get started with it. Okay, so when we talk about architecture in BIM, let's start with the concepts and process that is involved in planning a residential house. So when we talk about a residential house, what do we first do whenever you'll have a project in hand which is related to a residential house, or which involves concepts related to residential house planning? You'll first need to conduct a client meeting. You need to go visit the client and ask for the client requirements. So what are the steps involved? Let's talk about the steps that are involved in residential house planning. So first things first, we need to know the requirements of the client. So you visit the client, you ask him for the requirements, whether like the number of members in his family, the people who will be living in the family. So understanding the nature of people that are going to live in that space also becomes very important. How? That we will see in the upcoming slides. Okay, so we need to first know the requirements of the client, whether he needs a 1 BHK house, 2 BHK house, who are the people living in that house. We need to learn about the habits and nature of the people living in the house, so that we can design the space accordingly. Then we need to know the site information. We physically go to the site, measure the dimensions of the site, and compare those dimensions with the layout on paper that we are having, and cross verify whether the site dimensions are matching with the dimensions that we of the layout that we have on a paper. And then we need to know about building zones. What are building zones? We will get to learn about this in the upcoming slides. Bubble diagram. What do I mean by the bubble diagram? We just locate the rooms in the space, which room will be located where. Okay, that also we will be seeing in the upcoming slides. And then building bylaws. What do I mean by building bylaws? If you'll consider your own houses as well, okay, what you will be able to see is the plot size that you are having and the house that you are having. There are certain spaces left from the side, from the left, from the right, from the rear, and from the front. So it from the left, from the right, from the front, and from the back. Okay. So on what basis do we need leave these spaces from all the four sides? They are based off a book called as building bylaws, which is different for different places. For, let's say, for Maharashtra, we have a different set of building bylaws. For Karnataka, we have a different set of building bylaws. So we will see what building bylaws really mean. So we have the floor area ratio, we have the concepts involved in planning, then the aesthetics, anthropometry, working drawings, and interiors. Okay, so let's talk about all these one by one. Okay. Mm, Let me erase this. Let's move to the next slide. So what are the requirements of a client? What are the requirements of the client? So it can be when we visit the client, we need to collect certain information from the client, based on which we are going to plan the space. So let's talk about space planning. What does space planning exactly mean? So space planning is nothing but deciding the location and sizes of the rooms in that particular space. Now, what does this depend upon? It depends upon the purpose and for which we are designing that space, and on the client requirements. We can have different purpose for which we are designing that space. For example, in this case, we are designing a small residential house. So the purpose becomes residential planning. It could be a hospital. It could be a hospital building for which we are designing that space. It could be a commercial space for which we are designing that space. It could be a sports complex. It could be a restaurant. It could be anything. Okay. So based on the purpose for which we are designing that space, we need to do the space planning for that particular space. Along with that, we also need to learn about the client requirement. So what does space planning depend upon? It depends upon the purpose and the client requirement. So client requirement, you need to go and ask the client. So the client is going to tell you that he needs it 1 BHK house or 2 BHK house, 3 BHK house. If it comes to hospital building, he might tell you all, like, the purpose for like for what purpose is we need to design that space. So on the basis of the machinery that will be required to be placed in that particular space, we design that particular space. Okay, so it depends. So what is space planning? Space planning is nothing but it is a process in which we decide the size and space, okay, of different rooms in that space, depending upon the purpose and client requirements. Now, what are the other factors that we need to consider while planning the space? The other factors, it can be, let's say, sunlight entering the house. So you can usually place your kitchens, dry balconies, or common areas in locations such that maximum sunlight is received from that direction. Okay, or you can also consider placing your bedrooms or places that you usually use to relax yourself, like like bedroom, or it could be hall, or it could be any sitting area on the cooler side of the location. Along with this, you also need to consider circulation, movement of the people. So there are a lot of factors. We need to consider scale, anthropometry. We need to consider a lot of other factors. We will see them one by one. So the basic aim was to understand what is space planning. It is nothing but a process of deciding the size and location of the rooms. Okay, location of the rooms, depending on what? Depending upon the purpose and the client requirements. So we are talking about client requirements here. So what are the requirements of the client? So when we go and conduct a client meeting with the client, when we go and meet the client, we need to gather certain information from the client. So what is the information? It could be, let me change the color of the pen. So it could be the number of number of residents living in the house. It could be husband, wife, their children. We also need to study the nature of the people and their habits, major functional spaces and its uses. Like for example, if there are children that will be living in the house, we need to have different ideology or different way of thinking to design a space for them. If all everyone living in that house are adults, we need to have a different mindset while designing the space. Also, we need to design the space from future aspects. It's not that the children are not going to they're not going to grow. So when the children grow up, the space has to be utilized in a more optimized way. So we have to design it in a way such that now they're children, so we have to use we have to design it in a way that it can be maximum utilized by the children. But we also need to keep in mind that they're going to grow up and they even need to utilize that space in an optimum way when they grow up as well. Okay, so number of bedrooms required by them. Anthropometry. What is anthropometry? It is nothing but the science of studying the dimension of the human body. So that we will be seeing, that we will learn in the upcoming slides. So parking space numbers and vehicle model, especially for apartment buildings, you need to know how many number of vehicles have to be parked in the parking area and the space required by each vehicle. Okay, so do they have any special requirements in the mind? So usually what happens is, if the client does not have any idea of how space planning is done, we usually design that space according to Vastu principles. But let's say we have a water body somewhere in the location, and your client is very particular that while your client is relaxing in his hall area, he wants a view of that water body. It can be a sea, it could be any other water body. So you need to make a note of any special requirements that are there in the client's mind. It could be any other special requirements. And then you need to know about the water supply and drainage in the site and financial status of the client. Because when you do the space planning, you also need to know what budget you have to fit in. Okay, you cannot exceed the budget, or you cannot do plan something in a way that is below the budget. So according to the budget, you have to produce the space plans. Site information. So what now, once you visited the client, you collected all the data from the client, next thing that you need to do is you need to conduct a site visit. So when you visit the site, is the information that you need to collect from the site? So it will be site dimension and its direction, whether it's north facing, east facing, west facing, and the dimension. And this dimension you need to cross verify with the dimension on the paper, on the site layout. Okay, and then site surveying, you need to define the boundaries of your plot. And then soil checking, the type of soil that is present on the site. Okay, and then whether it's hard soil, medium, stiff soil, clay soil, the type of soil. And also note its SBC. Okay, conducting SBC of the soil is very important, that we will see when we take the structural part. Okay, so we need to check the soil, then the surrounding road dimensions and the direction of slope. This is also very important. Water bodies near the site. Okay, and the site surrounding. Why we need to note all these things, we will see in the upcoming slides. Okay, so let's see building zones. Okay, so when we talk about building zones, what are building zones? For the purpose of these regulations, local planning area, now I've taken the example of Belgaum, it could be any place, is divided into the following zones. Okay, so residential zone, it could be commercial. So it is divided area wise. You cannot construct a commercial building in a residential zone. You cannot construct residential houses in commercial areas. So you need to know the area, building zone of that particular area. So it could be commercial, it could be industrial, it could be open spaces. public or semi-public, public utilities, it could be a monument area, it could be only for transport and communication, or it could be for agriculture. So you need to know the building zones, the zone that is specified for the construction of that particular buildings only. Okay. So bubble diagram. Now what is bubble diagram? What do I mean by bubble diagram? So from here we begin with the concepts of residential house planning. Okay. So bubble diagrams are like, okay, instead of this, we'll just talk about it pictorially. Okay. So let's say I have a, okay. So let's say, okay. So let's say this is my plot. These are the boundaries of my plot. These are the boundaries of my plot. Okay. So now we get a built up area here. We need to leave certain spaces. These are the boundaries of my plot. Okay, this is the boundary of my plot, and this is the built up area. We need to leave certain spaces on the left, on the left, on the right, on the front, and on the rear. Now these are called as setback areas. This we will see when we are studying building bylaws. Okay, so we need to leave certain spaces, and this is my built up area. So this is the area over which I can construct my building. Okay, now when we know the built up area, we first define the concepts. We first just locate the rooms, that is based on Vastu principles or based on the client requirement. Which room is to be located where? We are just defining the concepts, and I'm just going to draw a bubble diagram and locate. So I'm going to first, I know the location, okay, the directions. Let's say this is my north direction, north, south, east, and west. So I'm going to define the location of my rooms first. So I'm going to say that my hall is going to come somewhere here, my kitchen is going to come somewhere here, my master bedroom is going to come somewhere here, and my second bedroom can come somewhere here, my toilet and my bathroom can come somewhere here. So this is called as a bubble diagram, where we are just conceptually locating the places or the areas where we are going to place our rooms. We have not defined the dimensions, we have just located the rooms. We have just located the room. So locating these rooms in a built up area is called as producing bubble diagrams. Okay, so if we talk about bubble diagrams, so let's go back to the explanation. I like wedding seating charts. Okay, you make a list categorizing all the invitees and sort a list into the table placement diagrams. You select where and with whom they will sit according to the kind of relationship they have. In architecture and interior designing, you use bubble diagrams for arrangement and placement. That is just to arrange and place the rooms. You are using the concepts of bubble diagram. Is the form of circle and oval shown, like if you see here, we just draw circles and ovals to define where our room is going to be placed. Okay, each circle or bubble represents a space to carry out a function such as dining. So let's say we are defining these spaces. These bubbles are nothing but spaces that we have defined. So garage, this is my bedroom, this is my bedroom here. Okay, this is my kitchen here. So every room is associated with carrying out of certain activity in that space. So we are just locating these spaces where certain activity is to be carried out, and we are just bubble diagrams. And so those circles get you involved in functional aspects of design such as privacy, circulation, noise, daylight, etc. Okay, so we'll understand this with the help of a real example now. So this is a real project wherein the size of my plot was 30 feet by 45 feet 3 inch. Okay, so here we are going to start off discussing with the concepts of space planning. So this is for a residential house. In the upcoming videos, we are going to take up the concepts related to other space plans, such as if the requirement is a commercial space, apartment buildings, it could be a hospital building, it could be a restaurant. For every, we will be discussing other concepts as well. But in this video, we will just talk about the concepts, design, and modeling of a small residential house. Okay. So, what is the first step? Step one was understand the client requirements, plot size, road position, and north direction. So, we went to the client. What are the client requirements? We have discussed it previously. So we discuss those requirements with our client. We see the plot size. We measure the plot size on paper. We measure the same plot size on site, and we see whether the measurements on the site are same as those measured on the paper. Okay. The road position, very important. We need to know the direction on which the road is present. So in this particular, we need to know the directions first. So this is my plot. This is my plot here. Okay, and this is my north direction here. This is my west, this is my south direction, this is my south direction, this is my north direction. Top we have west direction, and at the bottom we have east direction. So this is a east facing plot because the road is present on the east side of my plot. Okay, so this is the east facing plot because the road is present on the east side of the plot. And then north direction, we very important to note the north direction. So we have noted the north direction. But let's take the example of this particular project. The client requirement was 2 BHK house consisting of a hall, a kitchen, utility, puja room, dining, bedrooms with common toilet and bathroom area, only bike parking and no car parking. Okay, so what was the first step? As I had mentioned, we need to leave certain setbacks. Now this is my whole plot area. This is my whole plot area. This is my whole plot area. Now we need to leave certain setbacks. Okay, on the right, on the left, on the front, and on the rear side of my plot. These are called as setback distances, and these are usually for circulation of air and for maintenance purposes. Okay, maintenance purposes in the sense, like let's say you have a pipe, plumbing pipe located on the outer side of the building. So if your building is like fully occupied with the space, the plumber cannot climb up and repair this repair the services. So you need to leave certain spaces from all the four sides for repair and maintenance purposes. And another reason being easy circulation of air and for ventilation purposes. So how do we leave these setbacks? So let's take this example itself. So let me erase this first. Okay, so first let's understand our directions. So our directions are front. So we have our front direction, we have a rear direction, we have right, and we have left. So how now if you see, this should be left and this should be right, but why have we mentioned this as right and this as left? So to understand these directions, just imagine yourself standing in the middle of the plot. You're just standing in the middle of the plot and facing the road. You're standing in the middle of the plot and facing the road. So when you're facing the road, the side of your plot, the side of your plot which is parallel to your road is called as the front side. Okay, is called as the front side. Opposite to the front side, you're going to have rear side. And this is your right, this is your left side. So this is how we are going to define the directions. So once you know the directions, that is front, rear, right, and left, you now need to let me erase this. You now need to decide the setbacks that are to be left on all the four sides. Okay, so let me Okay, let's say, okay, instead of this, what I can do is, first let me measure the dimensions. Where is this? Okay, so I need to know the setbacks that I need to leave on the left side, on the right side, on the front, and on the rear. So you know how to define these directions now. So let's go to the setback table now, and we have this building bylaws setback table. We have this setback table. So when we talk about this setback table, you have width and depth of the site. So let's understand what is the width of my site and what is the depth of my site. So let me erase this. So okay, I will also write it down here. Okay, so I have my rear side and I have my front side. So we need to understand width and depth. So this is my front side, this is 30 feet. Front side is how much? Is 30 feet. This is 30 feet. From where did I get 30 feet? From here, 30 feet. So this is 30 feet, and this is this dimension is how much? This is 45 feet 3 inch. Okay, so when we talk about these dimensions, now this dimension, that is which is parallel to the front side, okay, or along the parallel side, okay, this dimension that is 30 feet, this is nothing but the width of your side, which is width of your side. The side of the side which is parallel to the road is nothing but the width of your side. And a perpendicular direction dimension, so this dimension which is perpendicular to the width, this is the depth of your plot. This is the width of your plot which is parallel to the road, and this is the depth of your plot which is perpendicular to the road. So I now know the width of my plot and I know the depth of my plot. So the width of my plot is the dimension which is perpendicular to my parallel to my road. Width is parallel to my road, and depth is perpendicular to my road. Okay. So depending upon the width, okay, depending upon the depth and width of my site, I'm going to define the setback distances. So I'll just write it down here. Okay. So what are the where do we need to leave the setbacks? First, we need to leave the setbacks on the front and on the rear end, on the front and rear end. Okay, now the setbacks that we need to leave on the front and rear side of my plot depends upon the width, depends upon the depth of my plot. Again, I'll just write it down here as a note. The setback distance that we need to leave on the front side and rear side of the plot depends upon the depth of the plot. So this is the depth of my plot. This is the depth of my plot. This is the depth of my plot. And this is the width of my plot. Depth is equal to 45 feet 3 inch, and width is equal to 30 feet. Okay. So now the next thing. So let's define the setback distance on the front and rear end of my plot first. So let me erase this. Let me erase this, and okay. So let's go to this column first. Okay, so we are defining the setback distance on the front side and on the rear side of my plot. So what does the setback distance, what does the setback distance depend upon? So the setback distance that is to be left on the rear and front side of my plot depends upon the depth of my plot. Depends upon the depth of my plot. And the depth of my plot is 45 feet 3 inch. So we need to convert 45 feet 3 inch into meters first, because everything mentioned here is in terms of meters. So 45 feet 3 inch, if we convert it into meters, it comes to around, it comes to around, I guess, 13 feet. Just divided by 3 feet 3 inch, and it comes to around, let me just calculate it once. Mm, it comes to around 13. It comes to around 13. You can calculate it. I may be wrong because I just calculated it roughly. Okay, so 3 feet 3, so I'm getting 13. So if you see, 13 lies in this range. 13 lies in this range. That is 13 meters up to 19 meters. So where do we need to leave the setback distance? On the front, on the front side and on the rear side of my plot. So front and rear. So I got the range from 13 meter up to 19 meter, and it is a residential building, and I need to leave the setback distance where? On the front and rear. So in the front I'm going to leave a distance of 2 feet, and on the rear I'm going to leave a distance of 1 2 meter, sorry, 2 meter, and on the rear side I'm going to leave a setback distance of 1.5 meter. So this is what we have done here. So 2 feet. I've left a setback distance here, or let me just calculate it here. Here I'm going to leave a setback distance of 2 meters, sorry, 2 meter, and here I'm going to leave a setback distance of 1.5 meter. Okay, 1.5 meter comes to around 5 feet, and 2 meter comes to around 6 feet 6 inch around. Okay, so I now know how to calculate the setback distance on the front and rear side of my plot. Now, what we need to leave the setback distance on the left and right side of the plot. So let me write another note here, possibly in another color. That is, this is very light. The setback distance that we need to leave on the left and right side of the plot of the plot depends upon the that we need to leave on the left, and depends upon the width of the plot. Depends upon the width of the plot. So what is the width of my plot here? If I see the width of my plot, that is 30 feet. Okay, if I go to my setback table, if I go to my table here, okay, so let me erase this. I will write it again. If we, okay, so if we see, let me erase this as well. Okay, so hmm, so it depends upon the width of my site. Okay, the setback that is to be left on the left side and on the right side of my plot depends upon the width of my plot. The width of my plot is 30 feet. So 30 feet comes to around 9 meters. Okay, say 9 meters. So 9 meters comes in this range. That is over 7 meters up to 10 meters. Okay, 9 meters it comes to around. 30 feet comes to around 9 meters. So It is a residential building again. So residential building again, and we need to leave the setback on the left side and on the right side of my plot. Okay, so this is 1 meter and 1 meter again. So I go back to this table. So here I need to leave a setback distance of 1 meter. Here I need to leave a setback distance of 1 meter. So I'll just draw a line. This is 1.5 meter. This is 2 meter here. I'm just drawing this roughly. This is 1 meter here again. This is 1 meter here again. So I'm going to join all of these, and this is my built up area. I need to leave these setback distances, and this will be my built up area. So this is how we leave the setback distances based on the building bylaws setback table. Okay, I hope this is clear. And this is what we get. This is how we get the built up area. So what I've done is, we have left the setback distance of 1 meter, 1 meter here, and here I've left a setback distance of almost more than 2 meter. Okay, almost more than 2 meter. And here also you can leave a setback distance more than that, more than what is mentioned or more than what you have calculated, but not less than what you have calculated. And here as well, I've left a setback distance of 5 feet, almost 5 feet. That was 1.5 meter. So this is how you leave the setback distance, and this is the built up area. So this is, so all your rooms should be placed within this built up area only. There are certain exceptions like staircases, one bathroom. So we will talk about those exceptions which you can bring outside your setback distance. But for now, just remember, this is the built up area, and this is the area in which you need to construct your entire structure. Okay, there are certain exceptions that we will talk about in the later part of the session. That is, you can construct your staircases or one bathroom balconies in your setback distance, but we will talk about them at a later part. Okay, now once we decide the setback distance, okay, we get the built up area, and in this built up area we locate our rooms using bubble diagram concept. Okay, so as we had discussed here as well, so we just locate our rooms. We decide that according to Vastu principles. So we will discuss about Vastu principles as well. So but before that, we just decide the location of our rooms. We just decide the location of our rooms using bubble diagram, and later we convert these bubble diagrams, these circles, into squares. So once we decide the location of our rooms, okay, so here you can see, once we draw the circles, we convert it into rectangles, and we decide the location of our rooms. So this is my hall. So let's discuss about Vastu principles and how we have decided the location of the rooms. Okay, so the client requirement was a 2 BHK house. Okay, so 2 BHK house, main entry into the house should be preferably from the east or north direction. So entry should be either from the east. So this is my east direction. So the entry should be either from the east, from the north direction, from the here, or from the northeast direction. So usually when we enter the house, we have our hall located here. So the hall can be located either in the east direction, or in the north direction, or in the northeast direction. So we have all the Vastu principles here, which are discussed in short. That is, the main entry into the house should be from the north, from the east, or from the northeast direction. So if you see living room should be in the northeast direction. So this is the north direction, this is east direction, and this is the northeast direction. So I have located my living room here in the northeast direction. Living room is placed. Next is kitchen. We are just discussing the Vastu principles here, because in majority of our space plans we follow Vastu principles. If there is a certain client requirement, let's say there is a water body here, Let's say there is a water body here, and your client has a specific requirement saying that he wants his hall or his living room to be located in a way that he should be able to visual he should be able to see the water body from that particular location, from, let's say, from the hall. That is where you can place the living room here. Otherwise, if the client says you just design the space plan and give it to me and I will evaluate and let you know about these changes, we usually design the space plans according to Vastu principles. So living room is done. Kitchen should be in southeast direction, and the position of your stove should be facing the east direction. So this is your south, this is east, and this is your southeast direction. So you can see your kitchen is located in the southeast direction. This is your kitchen, and stove should be preferably in east direction. So you can place your stove somewhere here. Okay. Then next is puja room should preferably be in the east or northeast direction. So this is your puja room, and this is preferably placed in the east direction. Master bedroom should be placed in the southwest direction. So this is your south direction and this is your west direction. So your bedroom too should be located here, and master bedroom should be placed in southwest. So this is your south and west. This is the location of your bedroom here. Okay, in the northwest or southwest, bedrooms and toilet. So one bedroom is here and one bedroom is here, and your toilet and bathroom we have placed it here. So this is how you locate your rooms according to Vastu principles. Okay. So you saw how you decided, how you just located the rooms now. So now we will discuss another important thing, that is deciding the size of your rooms, which is very important. Now when we can talk about BIM, Vastu principles are not that important here, because you get a lot of projects and it depends upon the client requirement, but the concepts behind deciding the size of your rooms is very important. Vastu principles is fine, it's not that important in BIM, but when it comes to building information modeling architecture in BIM, or when you consider architectural planning, deciding the size of your rooms is a very important aspect. So we will talk about, so FAR is nothing but, FAR helps you defining the number of floors that you can construct. So you have the number of floors here. We have floor area ratio. This is usually given in the building bylaws again. That is, you have different. Let's say this is a residential building, and you have, like, let's say, the road width. FAR also depends upon the road width. Let's say the width of the road which is there in front of your plot is 6 meter. Okay, and maximum plot size, let's say it is up to 150 meter. Then when it is a, now this, again you have another table which is area wise. Okay, so you need to refer to that table, and you need to see whether the area where you're constructing your house is intensely populated area or moderately populated area. So let's say it is moderately populated area and it is a residential area, and then it is a residential building that you're constructing, then the FAR to be taken is 1.25. Okay, so when it is 1.25, let's say this is 1.25 is equal to number of floors into floor area. Floor area. Now what is this floor area? This is the cumulative of built up area of all the floors. So this you can see here. So this is your floor area. This is your total floor area. This is your total floor area which I am highlighting. This is your total floor area. This is your total floor area, and this is your built up area. So you need to calculate the total built up area on all the floors. Okay, so number of floors, okay, into floor area. So here you just take the floor area of one area. Okay, so floor area into total area, and then total total area into FAR divided by the floor area of one floor will give you the number of floors that you can construct here. Okay, so FAR table here. Now comes deciding the size of my room. Deciding the size of my different rooms. Size of my hall, size of my kitchen, size of my bedroom, size of my toilet, bathrooms. So how do we decide the size of our rooms? So now when we consider deciding the size of our rooms, there are certain aspects that we need to consider. That is anthropometry, scales, and proportions. Now let's see what is anthropometry, what are scales, what are proportions, and how these terminologies help us in deciding the size of our rooms. So, to talk in general, anthropometry, scales, and proportions influence the furniture layout of a room. Anthropometry, scales, and proportions, okay, these influence the furniture layout. And depending upon the furniture layout, we decide the size of our rooms. So what we do is we go to the client, we ask him the number of people that will be living in the house, and we study the nature of people living in that house, and then we consider these principles, that is anthropometry, scales, and proportions. Using these principles, we define the furniture layout. Depending on these principles plus the client requirement, plus the client requirements, okay, these principles plus the client requirement help us in defining the furniture layout of that particular room or the furniture layout of the entire house. Let's say we have a family of four living, wherein we have the husband, wife, and two children. Okay, so we have four people living in that house. So the furniture depends upon, like, we have, since we have four people living, we define the furniture layout in a way that four people are comfortable, with that particular furniture. Now, how do we define the furniture layout? According to the client requirements, as I told you. Plus, we also need to consider anthropometry, scales, and proportions. So, how do we consider these? Anthropometry. So, what is anthropometry? Refers to the measurement of human individual. It's a systematic measurement of physical properties of the human body. What are the physical properties of the human body? The height, the human height, the width. Okay, majorly height and width of the human body are considered a physical aspect. Now, when a person is sitting on a chair, what is the total area that the person is occupying? What is the total space that will be required by that particular person when he's sitting? When he's standing, what is the total area? What is the total area he is occupying just to stand? So we define, certain standard spaces that are required by the human body. For example, when he's sitting, what is the space occupied? When he's standing, what is the space occupied? So there are basically two types of anthropometries, that is static anthropometry and functional anthropometry. What do I mean by static anthropometry? It helps us in defining the space required by a human body for different activities, for static activities. When a person is sitting, when a person is sleeping, when a person is lying down, what is the space that is required by the average human body to perform that activity? That is your static anthropometry. Let's say a person wants to sit on a chair. So what is the space that will be required by that person just to sit? That is called a static anthropometry, because these are static activities: sitting, standing, sleeping, all this. The space that is required by a person when he is sleeping. Okay, these are static anthropometries. Functional anthropometries help us in defining circulation spaces. Circulation spaces in the sense, let's say I have a bed placed in my bedroom. Now I need certain spaces on on either side of my bedrooms, so that I can move around, as well as I can change bed sheets as well. So what do I mean by functional anthropometry? The space that is required by the for the movement of the human body to perform day-to-day activities, such as, like, changing the bed sheet is one specific example I give. So usually a space of around, or a width of around 700 to 900 is to be left on either side of the bedroom. Okay, a minimum space of 2 feet 6 inch to 3 feet is to be left for the movement of human beings around. Okay, so anthropometry is taken into consideration just to study the space that is occupied by a human body to perform either static activities or functional activities. Static in the sense sitting, standing, sleeping, what is the space required by that human body, or functional anthropometry just for that human body to move around. It shouldn't be too congested that the human is not able to move at all, or to perform various functional activities such as changing bed sheets and then sweeping the floor. All those things also have to be considered. So for us to calculate, okay, the space that is required by a human body to perform everyday activities, we have this, we consider anthropometry, studying anthropometry, that is the study of human body dimensions. So when we talk about human body dimensions, okay, the average when we are you know preparing the furniture layout, the average height of the human body is considered as 1800 mm. Okay, as 1800 mm, and the average width of the human body is considered as 450 mm. This is very important. Okay, so let's say we are that we need to place a study table along with the chair. So how much space will be occupied? Okay, so let's say the height of my table is 750 mm, and then for that person just to sit on that chair it requires 500 mm of space, and the width of the chair is 600 mm. So when he's standing, the height of the chair and then the width of the table is also to be considered, like depending upon the different widths of the table. Okay, and then when he's standing, the shelf, okay, the shelf, if there is any shelf, this should be at the bottom of the shelf, should be at a minimum distance of 1500 mm. So we need to study all these things, anthropometry. Okay, this is the study of human body dimensions. And then we have anthropometry again. This is sitting anthropometry. You can just have a look at the dimensions here. Crawling anthropometry. Okay, and then we have washroom anthropometry. That is the height of the sink should be at a minimum elevation of 850 mm. The height of your toilet seat, then the height of your any hanger if you have here, then this is your sink here. Okay, so minimum 900 mm of width space is required for the sink, and you need to have a clearance space of 500 mm. This is your toilet anthropometry. Okay, this is for your shower area. Then beside the bed, as I told you, just to change the bed sheets, you need to leave a space of around 700 mm. It can be 700 mm to 900 mm. Walking past a bed, that is for your movement. That is two types of anthropometry which I told you: static anthropometry, functional anthropometry. So this is functional anthropometry, moving around in space. So you need a minimum distance here of 2 feet 6 inch to 3 feet through 3 feet just to move around. Okay, 700 mm here, and then for movement you have around 900 mm space. Okay, so static anthropometry and dynamic static anthropometry and functional anthropometry. Now let's talk about what are scales. What are scales? So what do I mean by scale? Scales define the relationship between two objects. What are scales? They define the relationship between two objects. So in this example, you can see a person sitting on this chair. So chair is one object and human is one object. So you can compare anthropometry with any of the objects in that particular space. Like for example, for this person to comfortably sit on the chair, what should be the ratio? What should be the ratio of the space that the chair is occupying and the space that the human body is occupying? So usually we will talk about spaces as well. Usually we don't follow ratios of 1 is to 2 or 1 is to 1. You usually go for ratios like 2 is to 3, 3 is to 5, or 5 is to 8. These ratios, these should be avoided. Okay, so scales are nothing but relationship between two objects. Here we can see the relationship of a object with anthropometry. So we discussed about what the anthropometry, study of human body dimension, and this is a chair. So it should be in proportion so that it looks aesthetically pleasing and it is comfortable. We can take the example of a room, okay, a room and furniture here, okay. So these two should be in scale. It should not be that the room is very small, and the furniture is too large here. It won't look very good. So these two should also be in scale. That is, the room should be in proportion to the, or the furniture should be in proportion to the room size. It shouldn't be that the room is very large and the furniture is very small, and or it shouldn't be that the room is too small and the furniture is too large. It has to be in certain scale and proportion. So usually these scales and proportions are avoided, that is 1 is to 1 and 1 is to 2. Usually 2 is to 3 or 3 is to 5 or 5 is to 8 is preferred, okay. Scales. And then we have proportions. What is proportion? Proportion is the comparison or the relationship between parts of the same object. Relationship between parts of the same objects or objects of the same category. Now, for example, let's say I have a sofa here. Okay. So let's consider the length and width of the sofa. So these two are the parts of the same object. So it shouldn't be that the length is too long and the width is very small. Okay. Or let's say I have a sofa here and I have a chair placed, or let's say this table here. Let's say I have this table as well here. So it shouldn't be that this sofa is too small. So these two are of the same category. These come under hall furniture. Okay, so furniture that is placed in the hall. So it shouldn't be that this table is too small and the sofa set is very large, or the table is very large and the sofa set is too small. So the relationship between these two objects of the same category or the parts of the same object. Let's say this sofa leg here. Okay, sofa leg is very long and the width is very small, so it will look very odd. So this should also be in proportion. So we usually avoid 1 is to 1, 1 is to 2, it should be avoided, 1 is to 2 should be avoided, and we usually follow ratios of either 2 is to 3 or 3 is to 5 or 5 is to 8. Okay, these are comfortable and aesthetically pleasing when we look at them. So now, on the basis of anthropometry, scales and proportions, we are going to decide the dimensions of the furniture we are going to decide the furniture layout. Okay, the standard furniture layouts on the basis of anthropometry, scales and proportions. Okay, so we have certain standard sizes of furniture, okay, depending upon which we are going to decide the size of our rooms. Okay, so let's talk about furniture layout. What is furniture layout? Okay, so furniture layout, depending upon the scales, proportions and anthropometry, we have certain standard sizes of a table. Okay, let's talk about deciding the size of a hall and dining room first. Okay, depending on the furniture layout. So depending upon anthropometry, scales and proportions, the standard size of a table, deciding the dimensions of the dining table. What is it? If let's say your client says that he needs a dining room for 8 people. So when it comes to 8 people, this is the standard size of the dining table, which is comfortable for for number of people being 8. Let's say the client says that he only wants a dining table for, let's say, 6 people. So this is like the ideal size of the dining table. Let's say for only 2 people, this is the ideal size of the dining table. So we are going to place the dining table here. So this is the hall, living room. So this is the dining table. So this is for a number of people being 5 here. Okay, so 2 4, you can keep 5 and you can add one more chair here. Okay, so this is the space that will be occupied, 3 feet by 6 feet. Okay, 3 feet by 6 feet. So once you place the dining table, make sure you have adequate space around for the movement of human beings. So 2 feet 10 inch. Okay, so anywhere between 2 feet 6 inch to 3 feet is the minimum size, minimum space that is required for the movement of human body. Okay, so I have a space of 2 feet 10 inches, so so human beings can easily move around here. Okay, so this is 6 feet and this is 3 feet, so this dining room is comfortable here. Okay, so depending upon this, we are deciding now how do we decide the standard sizes. We are going to talk about this as well. Okay, so when we talk about hall, okay, and then comes the size of your sofa. Okay, so let's say your client says that he wants a hall, he wants to place sofa in the hall in a way that four people should sit comfortably, so you can place two chairs, okay, and a table. So depending on these dimensions, you're going to decide the dimension of the room. Okay, and then three-seater sofa, four-seater sofa, so these are the dimensions that are mentioned here. Okay, standard dimensions. So depending upon these dimensions, now how to decide the dimension? So range of room sizes. Okay, depending upon the client requirement. Okay, again, the minimum size of your hall or living room should be 10 feet by 12 feet. Try to keep the size of your hall or living room as 10 feet by 12 feet. Okay, let's say it is for four people, then you can keep the size of your living room to be 10 feet by 12 feet. Once you decide the size of your dining room to be 10 feet by 12 feet, you need to place your furniture. You need to place your furniture and see if the layout is not very congested and if the movement of human beings is very smooth. Okay, so you decide the size of your rooms first. Start from 10 feet, 12 feet, 10 feet by 12 feet, and try placing the furniture according to the client requirements, and make sure that there is easy movement of human beings according to anthropometry. You follow scales and proportions, and then also the dimensions of each of the furniture should be such that they should be comfortable for the human body to be adjusted or to relax. Okay, if let's say the client requirement is certain high, let's say he says five people, then go for a larger room. Or let's say he knows the definite furniture that is to be placed in the hall, so go on increasing the size of your hall here, but don't go beyond this, otherwise it will become too large. Okay, it will become too large, so just try to keep the size of your hall in this range. Okay, so these room sizes are decided on the basis of client requirements as to what components he wants in a particular living room. Okay, so components of a living room, usually they are sofa and TV unit.